Could there be a massive, undiscovered planet hiding in the farthest reaches of our solar system, just beyond the familiar orbits of Neptune and Pluto? The idea of a Planet 9 is no longer just a distant dream or a passing theory. More and more astronomers are now convinced that it's real. And this is not just based on vague speculation, it's grounded in solid evidence and data that has been carefully analyzed and interpreted over the years. Strange anomalies in the Kuiper Belt, those icy remnants from the birth of the solar system, are now seen as the telltale signs of a massive, unseen planet lurking at the very edge of our solar system, just waiting to be discovered. But why has this planet stayed hidden for so long? And what has led scientists to believe this planet is real? The search for Planet 9 began with a simple but profound question: where do comets come from? That in the early 1950s, Dutch astronomer Jan Heinrich Oort proposed a groundbreaking theory to explain the origins of long-period comets, those icy bodies that take hundreds or even thousands of years to orbit the Sun. Oort suggested that these comets came from a vast cloud of icy objects at the outermost edges of the solar system, which he called the Oort cloud. This idea would go on to shape our understanding of the solar system's distant fringes. But while Oort's theory helped explain where long-period comets came from, it didn't account for the short-period comets, which orbit the Sun in much quicker intervals. Enter Gerard Kuiper, another astronomer who in the 1950s proposed the existence of the Kuiper Belt, a disc-shaped region just beyond the orbits of Neptune and Pluto that contained short-period comets and icy bodies. That today, the Kuiper Belt is a well-established part of our solar system. It's a region filled with icy debris, dwarf planets and comets, stretching far beyond Pluto. But here's the twist: astronomers have long suspected that the Kuiper Belt might be hiding something much larger, a planet so elusive that we failed to detect it for generations. And this is where Planet 9 comes into play. The idea that a giant planet could be lurking beyond the known planets of our solar system isn't as far-fetched as it sounds. In fact, the possibility that such a planet exists has gained traction over the past decade, thanks to discoveries made by some of the world's leading astronomers. The potential location of Planet 9 is far beyond the reaches of Neptune and Pluto, at a distance so extreme that it would be nearly invisible to our current telescopes. But astronomers aren't just relying on direct observations to find this elusive planet, they're also looking at the subtle clues left behind by other objects in the solar system. One of the key players in this search is Michael Brown, a renowned American astronomer who's been studying the icy worlds at the edge of our solar system for years. Brown is famous for discovering the dwarf planet Eris, which contributed to Pluto being demoted from planet status in 2006. Brown, often humorously referred to as the Pluto killer, has a reputation for challenging long-held beliefs about our solar system. And in 2006, his work led to an even bigger revelation: the discovery of distant, detached objects, large icy bodies that orbit the Sun at great distances. These objects form the cornerstone of a study that would ultimately lead to the groundbreaking idea of Planet 9. Brown and his colleague Konstantin Bedigen begin investigating the strange orbits of these objects, which seem to share some puzzling characteristics. 6 of them, in particular, followed elliptical orbits that pointed in the same direction. This was perplexing because these objects were traveling at different speeds and followed orbits of different sizes. The common denominator? Their orbits were all tilted by about 30 degrees from the plane of the solar system. Could this just be a coincidence? Brown didn't think so. After conducting detailed simulations, he concluded that the only way to explain these anomalies was the presence of a massive planet, one with enough gravitational pull to influence the orbits of these distant objects. So why haven't we spotted Planet 9 yet? Well, according to Brown and Bedigen's models, Planet 9 is thought to be roughly the size of Neptune, with a mass between 9 and 10 times that of Earth. Its orbit would be incredibly distant, while Earth takes just 365 days to complete one orbit. Planet 9 would take a staggering 20,000 years to orbit the Sun. Because of this extreme distance, Planet 9 would be invisible to most of our telescopes. Not only that, but it would likely be very faint. Its intrinsic luminosity is predicted to be only 0.06% of Neptune's luminosity, making it even harder to spot. Furthermore, the radiation from Planet 9 would probably be in the infrared range, meaning it would only be slightly warmer than the cold space around it, with an estimated temperature of around 226 degrees 47 Kelvin. However, all hope is not lost. There's still a chance that Planet 9 could have been captured in the images of past sky surveys, especially if it was close to the Sun during its closest approach. But the real breakthrough may come in the form of next-generation telescopes, such as the Vera C. Rubin Observatory, which is scheduled to begin operations in 2025. Once it's up and running, this powerful telescope could be the key to finding Planet 9 and unraveling the mysteries of our solar system's farthest reaches. The hunt for Planet 9 is made even more fascinating by the fact that its existence challenges what we know about planet formation. Normally, giant planets like Neptune form in the outer regions of a gas and dust cloud surrounding a young star, where there's enough material to create large, dense planets. But Planet 9 exists far beyond the zone where such a cloud would have provided sufficient material for planet formation. So how could a planet that's almost the size of Neptune end up so far out in space, with such an eccentric orbit? To answer that, researchers have proposed three main theories about how Planet 9 might have formed. The first theory suggests that Planet 9 may have originally formed closer to the Sun in a nearly circular orbit, but was later pushed out into its current orbit by the gravitational influence of a passing star. However, this theory seems unlikely, as it would require the original gas cloud to have been much larger and more long-lived than current models suggest. Planet 9 from one of its sibling stars. However, this scenario is extremely rare, with only a 1% chance of happening. The third and most widely accepted theory is that Planet 9 was formed in the inner regions of the primordial cloud, just like Jupiter, Saturn, Uranus, and Neptune. Over time, gravitational interactions and turbulence could have pushed it outward, eventually flinging it into an eccentric orbit far from the Sun. While this theory is the most plausible, it still raises the question: how could Planet 9 have been pushed so far out without being ejected from the solar system entirely? Despite these intriguing theories, Planet 9 remains a theoretical planet so far. No direct evidence has confirmed its existence. But the search continues, and new technologies like the James Webb Space Telescope could provide the breakthrough we need to finally spot the elusive planet. If Planet 9 does exist, it would be a groundbreaking discovery that would expand our understanding of the solar system and the forces that shape it. Could it be the key to unlocking the last great mystery of our solar system? Only time will tell. So, what's the future of the search for Planet 9? With the tools and technologies currently being developed, it's possible that we'll find the long-lost planet sooner than we think. If you're fascinated by this cosmic mystery and eager to stay updated on the latest discoveries, make sure to hit that subscribe button, give us a thumbs up, and stay tuned for more exciting videos. You won't want to miss what's coming next.